So 5.3 is properties of definite integrals, rules we can use to simplify definite integrals. The first one, if you change the order of the limits of integration, so instead of integrating from a to b, you integrate from b to a, you end up with the opposite of the value that your original definite integral had. And here's a picture help us see. Remember, definite integral, just area under a curve. So if I want the area under this curve v from 0 to 4, I add up the areas of infinitely many rectangles. Well, when I integrate from a to b, from 0 to 4, then the width across this first rectangle is 1 minus 0, which is 1. If I change the order, if I'm integrating from 4 to 0, then this distance is actually 0 minus 1, and I have rectangles with negative width. So that's how I end up with a negative area, even if the area seems to be above the x-axis. Okay, next rule. If I integrate, if my definite integral has a lower limit and upper limit that are the same, then the value of that integral must be 0. Again, here's the picture. If, for example, I am integrating from 1 to 1, here, my rectangle has a height, whatever the function value is, but my rectangle has a width of 0. So that's how I end up with a total area under the curve of 0. Next rule, if my integrand has a constant multiplier, so see this k here that's multiplying, here we go, this k, that's a constant multiplier. I can factor a constant multiplier out to the front. So instead of leaving that k inside my integral, I can just factor the k out, evaluate the integral, and whatever I get, multiply by k. That's legit. It's similar to the constant multiple rule we had for derivatives. And similar to the sum and difference rule we had for derivatives, if I want to take the integral of a sum of two functions, or a difference, I can rewrite that as separate integrals, the sum of the separate integrals of the two functions, or difference. Oops. And one more rule for definite integrals, it's called additivity. So remember, definite integral, area under a curve. If I want to add together these two integrals, this is the area under f of x between a and b. This is the area under f of x between b and c. Well, if you look at the picture, you can see this is the area under f of x between a and b. If I want to add that to the area under f of x between b and c, that just makes the area under f of x between a and c. So if this upper limit matches this lower limit, then I can just rewrite this as one integral. So one integral with a longer interval. So 5 properties for definite integrals. Let's try them out.